In this podcast episode, Joe Rogan speaks with Avi Loeb, an astrophysicist renowned for his provocative theories about interstellar objects and extraterrestrial intelligence. The conversation unfolds with an immediate dive into controversial but fascinating topics surrounding recent astronomical discoveries, specifically interstellar visitors to our solar system, like the object named 3I Atlas. Loeb sets the stage by explaining the intense skepticism and misinformation that surrounds reports about these enigmatic visitors, and addresses the challenges of gaining scientific credibility when proposing extraordinary ideas. The discussion immediately establishes that the stakes of this inquiry are much higher than typical academic debates. They potentially have profound implications for humanity's understanding of its place in the cosmos. Loeb's perspective is shaped by a deep commitment to curiosity and humility in the face of cosmic vastness. He contrasts the usual approach in scientific institutions, which often dismisses anomalous data to protect existing paradigms, with his own insistence on gathering as much evidence as possible before forming conclusions. He expresses concern that history often shows scientific communities resisting revolutionary ideas, citing Galileo's persecution and more recent examples of resistance to new physics discoveries. This theme recurs throughout the conversation and sets the tone for a frank, exploratory, and at times critical dialogue about the scientific process and the resistance to paradigm shifts. A significant portion of the podcast centers on the peculiar interstellar object dubbed 3I Atlas, an astronomical visitor roughly the size of Manhattan Island that passed through the solar system with properties that defy conventional comet or asteroid classification. Avi Loeb explains that this object is much larger and more massive than the earlier known visitor, Oumuamua, and exhibits strange behaviors that are difficult to reconcile with natural physics. For instance, he discusses the object's trajectory, which aligns unusually well with the plane of the planets in our solar system and moves in a retrograde orbit. This alignment and behavior, according to Loeb, hint at potential intelligent design rather than random natural occurrences. Loeb emphasizes that 3I Atlas loses mass predominantly on its sun-facing side, but shows no expected recoil or acceleration effects typically associated with natural comet outgassing. The lack of a typical comet tail and the composition dominated by nickel rather than iron add layers of mystery. He underscores his advocacy for seriously entertaining the possibility that this object might be of technological origin, not just a natural rock. Despite mounting evidence and scientific papers outlining these anomalies, Loeb recounts how the academic community and journal editors often block or censor even speculative hypotheses that challenge orthodox explanations, illustrating a systemic resistance to considering extraterrestrial intelligence seriously. The episode delves deeply into the nature of scientific culture and why it often resists revolutionary ideas, especially those that carry social or ideological risks. Loeb portrays the scientific community as predominantly conservative, tending to favor incremental advances rather than radical concepts. Personal jealousy, fear of reputational damage, and institutional inertia lead many scientists to suppress or ridicule unconventional ideas, no matter how intriguing or evidence-supported they might be. The host and guest discuss the psychological and sociological mechanisms behind such behavior, where maintaining the status quo often wins over curiosity-driven exploration. This entrenched conservatism clashes with the rarity and importance of black swan events, low probability but high impact occurrences that can reshape human knowledge and society. Loeb draws parallels with intelligence failures like the 2023 Hamas-Israel conflict dismissals, underscoring how ignoring unlikely but consequential scenarios can cause catastrophic effects. Similarly, ignoring or marginalizing anomalous astrophysical phenomena could blind humanity to critical discoveries, including the existence of extraterrestrial intelligence. Loeb argues that there must be a more open culture in academia that rewards imagination, risk-taking, and the investigation of anomalies rather than suppressing them. Loeb stresses that interstellar objects like 3I Atlas and Oumuamua should be treated as potential bearers of evidence about alien technology, not merely ignored or assumed to be natural rocks. He points out that space is vast, with billions of stars and countless Earth-like planets, raising the likelihood that technologically advanced civilizations might have emerged before ours and sent physical artifacts or probes through the galaxy. Ignoring these objects without thorough investigation narrows humanity's chances to discover intelligent life. The discussion explores the notion that conventional science prioritizes searching for microbial life on exoplanets, a strategy likened by Loeb to peering through one's window to look for bacterial life in a neighbor's yard. However, detecting the presence of advanced civilizations could be achieved by directly studying anomalous interstellar visitors and their possible technological signatures. These might be easier to detect than subtle chemical signs of microbes on distant planets. Thus, Loeb advocates for a shift toward allocating significant resources to the search for intelligence in the cosmos alongside microbial searches. The dialogue also turns to Mars and the intriguing right-angled structures observed on its surface, leading to speculation about whether they could be remnants of past civilizations or just space debris that landed there. Loeb acknowledges that Mars and the Moon serve as astronomical museums, preserving debris and possible artifacts because they lack atmospheres that would erode surfaces. The right-angled patterns are hard to explain naturally, and investigating Martian caves like lava tubes where cosmic radiation is blocked could reveal preserved signs of past life or technology. Loeb weighs the scientific challenges, noting the harsh conditions and extensive bombardment by meteor impacts on Mars' surface that would degrade structures over billions of years. Nonetheless, he affirms an open-minded approach guided by evidence is vital. The possibility that Mars once hosted life, or even an earlier intelligent civilization whose remnants survive in protected environments, remains a tantalizing research frontier. The connections drawn between Mars's potential role in seeding Earth with life, panspermia, and ongoing exploration programs underline the importance of continued planetary science. The conversation shifts to contemporary challenges facing humanity, particularly the rise of artificial intelligence and its effects on cognition and social cohesion. Loeb voices concern that AI, while powerful, may drive humans into mental passivity by enabling easier access to information and prompting intellectual laziness. He warns that AI systems can manipulate minds, amplify misinformation, and deepen societal polarization, potentially hastening self-inflicted societal collapse or disorder. Loeb contrasts human biological intelligence, which operates elegantly on just 20 watts of power, with current AI systems that consume gigawatts and lack comparable adaptability. This stark disparity highlights how biology's evolutionary successes remain incompletely understood, and that the future of intelligence may combine biological and artificial elements in unprecedented ways. Nevertheless, he strongly advocates for responsible AI usage, coupled with a deeper appreciation of human creativity and critical thinking to avoid dumbing down society. Loeb critiques the prevailing scientific investment priorities that overwhelmingly favor searching for microbial life signatures in exoplanet atmospheres at the expense of exploring possible technological signals. While detecting microbes would be an extraordinary landmark, he finds the prospect less exciting compared to discovering intelligent beings who could actively communicate, inspire, or influence human civilization. He highlights initiatives like NASA's upcoming sample return missions from Mars as crucial, but insists that these should be part of a broader, multi-pronged search strategy. Searching for chemical fingerprints of industrial pollution or artificial light on exoplanets is an underemphasized method that could reveal active technological civilizations. Loeb envisions a future where billions of dollars are invested in such searches, including spacecraft intercept missions to newly discovered interstellar visitors. This multimodal approach is required because while microbial life may be common, the emergence and longevity of intelligent, technologically capable species represent a far rarer but more transformative discovery. Throughout the episode, Loeb recounts struggles with accessing data on interstellar objects, including imagery from NASA's Mars Reconnaissance Orbiter that remains unreleased due to bureaucratic holdups, such as government shutdowns. He expresses frustration that scientists outside government agencies face hurdles obtaining critical observations, slowing progress on understanding objects like 3II Atlas. This barrier is intensified by a culture of secrecy, competing priorities, and the politics of funding. Loeb also shares his limited but ongoing engagement with government institutions and the Pentagon's Old Dominion Anomaly Resolution Office, revealing contradictory messages about the existence of recovered materials from supposed extraterrestrial crashes. While some insiders hint at advanced materials and biological specimens, official sources deny or remain silent. Loeb's insistence on evidence and transparent data remains central to his approach, rejecting anecdotal claims until verification is possible, but encouraging open collaboration to enhance collective knowledge. Avi Loeb ventures into theoretical physics, entertaining radical possibilities for propulsion and technology that could explain or surpass current understanding of interstellar travel. Among these are concepts like negative mass-producing repulsive gravity, which could theoretically allow spacecraft to accelerate without fuel consumption. Such exotic physics, while speculative, open the door to imagining civilizations with capabilities far beyond human current reach. He also touches on the implications of potential advanced technologies, including time machines, enabled by such phenomena. Loeb points to his active research collaborations investigating these concepts, emphasizing the exponential potential of scientific innovation and artificial general intelligence to revolutionize space exploration and beyond. These ideas reinforce his overall message: the universe is likely far richer and stranger than conventional science often admits. Loeb discusses the Galileo Project, which he leads as the first dedicated scientific effort to systematically observe and analyze unidentified objects in Earth's vicinity and beyond. Utilizing advanced sensor arrays placed strategically, like atop the Sphere in Las Vegas, the project aims to collect high-quality, multi-perspective evidence on objects whose origins defy current explanations. The goal is to discern whether they represent human-made craft, natural phenomena, adversarial technologies, or truly alien devices. These observatories use machine learning along with infrared and visible light sensors to track millions of objects annually, enhancing scientific rigor and transparency in a field previously dominated by anecdote or secretive investigations. Loeb sees the Galileo Project as a blueprint for how society might responsibly monitor the skies for potential threats or breakthroughs alike. He encourages greater government involvement, suggesting that defense budgets could pragmatically support such initiatives given the national and planetary security stakes. Toward the conclusion, both Rogan and Loeb reflect on humanity's cosmic insignificance and the humbling realization that Earth is neither the center nor the pinnacle of intelligence in the universe. Loeb invokes historical examples like the Vatican's delayed acceptance of heliocentrism to illustrate how humankind's ego often obstructs scientific progress. He emphasizes that the universe likely harbors a diversity of civilizations, many far more ancient and advanced than ours, challenging Earth-centric assumptions. Loeb muses about the implications for religion, culture, and self-identity, suggesting that encountering extraterrestrial intelligence should be seen as an expansion of the cosmic family rather than a threat. This cosmic modesty, he argues, should inspire collaboration, curiosity, and a collective commitment to humanity's long-term survival and exploration. Ultimately, he presents the search for extraterrestrial intelligence as the most romantic and consequential question in science, inviting society to cast aside cynicism and embrace wonder.